Hey there, ladies and gentlemen, boys and girls. Today we're going to start with some of the basics. We're going to talk about the metric system. We're going to go over it real briefly, just some of the major ones that we would use in these courses. So first of all, we're obviously using the metric system in science. And the whole reason why we use a metric system, why there's this one system that we use in science, is because science needs to transcend cultures, borders, things like that, even languages. We need to create a system where a certain measurement is, this much is the same label in Turkey as it is in Japan, as in Australia, so on and so forth. That length there needs to be described the same way. And so the scientific community 100 years ago hundreds of years ago made up this metric system, the international metric system, to do this. Now, myself being American and many of you guys being American, we are grown up dealing with the old English system, and we are one of the few countries in the world that still use that in our everyday lives. I still use, I'm a science teacher, but I still talk about feet and miles and stuff like that in my everyday life. The concept is when in science, when we're trying to share our information with everyone else in the world, we need to do it in a system that is universal. And that's why we still use the metric system. Or what we use is what we call the SI units. SI standing for, it's what we call the International System of Units. All right, but it's called SI units because it's Latin for system international, which basically means International System of Units. There are 7 of them, or at least 7 standard ones that we should say. There are a couple more. There's mass, length, temperature, the amount of a substance, the electrical current, time, and luminosity. We are going to be talking about, out of those 7, we're going to talk about 4 of them. And then we're going to add one more, only because that's not technically an SI unit, but it's one that we talk a lot about in this class. All right, so this is why you guys have your notebooks out, hopefully, to kind of take some notes on it. We're just going to talk about basically what is that SI unit, what units we use to label it, like in the American unit system for weight, we use pounds, all right, or ounces. So what we do, so some of this should be reviewed, definitely should be reviewed. And then the most common tool we use to measure those things. So this should just be a nice brief reminder. So I'm going to go ahead and get right into it. All right. So first things first. So we have our SI units where, like I said, we're going to do 4 of the SI units, and then we're going to add one more to that. So let's just go ahead and start with one of the most basic ones. Let's start with mass. All right. Mass is something that's very common misconception that mass and weight are not the same thing. All right, weight is how much gravity pulls down on you. All right, if you're standing here on Earth, you have a certain amount of weight, but if you go to the moon, your weight has changed. Now, whether you're on Earth or the moon, your weight changes, but your mass stays the same. All right, and so the easiest way to describe that, basically, mass is the amount of matter in an object. I'm going to keep these terms really simple because I'm just trying to do this relatively quickly here because I'm not trying to confuse anyone here. Let me get a little better view for you. All right. The amount of matter. Now, the units that we typically use for this, most people are familiar with the gram. More often than not, we actually use the kilogram, which we'll talk, or in a different video, we talk about converting from grams to kilograms. Kilogram is 1,000 grams. To try and give you a little bit of rough, it's about a little over 2 pounds for our American viewers out there. And obviously, the most common tool that we use for this is either a scale or a balance. Most days, today, we use digital balances where we place the object on it, and it will give us a digital readout of the amount in grams or kilograms that object has. So it's the amount in kilograms of matter in an object. All right, and that could, depending where that object is, will determine that object's weight. All right, so let's do time. Okay, now time could be really, I could make some really fancy definition. We could go into Einstein and relativity and special relativity. We're just going to say basically it's the amount of, oh boy, how do I want to define this? I've heard this one before. It's a tough one because time is a very tricky thing to truly understand, or what we say to understand. It's basically the measurement of how we know things are moving forward, passing events. Um, we typically measure that one in seconds, very similar to what we do anyway. We don't really use minutes in the metric system. Um, we do seconds, just sometimes very large numbers. We could do kiloseconds, although that is not typically used, but milliseconds is used, especially in things like track and field and things like that. And we typically use some sort of stopwatch or a timer for that measure or for that tool. Next, let's do temperature. All right, temperature is a little tricky, and we spend a little bit more time talking about what temperature is. And basically, it's the amount of particle motion. So every material is made up of particles, and all those particles are moving. Even just some are just vibrating very slow or in a very, very small amount of space. How much they are moving at measurement is what we call temperature. So how much are the particles moving? So objects that have high temperature are moving a lot, and objects that have low temperature are moving very little. All right, and or the standard unit that we use for temperature in the SI unit is a scale called Kelvin, which we abbreviate with a capital K. All right. Oh, I should go back into the seconds. We abbreviate with the little s, and kilograms. Grams is little g, but it's kilograms, so it's a little k, little g. All right, now capital K for Kelvin. Kelvin is the actual measurement of how much particles move. Absolute zero is absolutely no particle movement. There's no negative Kelvin. So typically, like I'm sitting in a room in air conditioning right now. This room is probably at about 290 Kelvin. That's kind of a lot. All right, and these numbers are more for mathematical uses. So actually, a lot of times what we substitute for Kelvin, what we'll use instead is we'll use Celsius. All right, we'll use Celsius instead. And the tool we use for that is one that we're all, or should all, be pretty familiar with. Sorry, I'm running out of space here. Oops. Let's run just temperature. This is a thermometer. All right. Classic thermometer. That basically is going to measure how much the particle motion. We used to use mercury in those thermometers because mercury, although a metal, is actually a liquid. The more the particles vibrate near it, the more the particles of mercury will vibrate and cause it to rise up. And fortunately, mercury is somewhat toxic, and if it gets in the bloodstream, even through the skin into the bloodstream, it can cause brain damage. And so we don't use that anymore. We typically use alcohol that's been dyed red to make it stand out. All right, let's do length. Length's a pretty straightforward one. You've been measuring length of things since you were in elementary school. All right. Length, we typically measure, the measurement from two or between 2 points. Between 2 points, right? How long is something? Measurement between 2 points, and we typically use this in America. We measured in inches and feet. Again, that's an old English system that's not really used in the world. It's not the standard one we use. In the world, we use the metric system, which means it's based off of the meter. Now we'll talk about converting between meters and kilometers and centimeters and millimeters. just depending on how we want to modify that meter. And the tool that we typically use for that is either the meter stick, or just kind of more everyday life is the ruler. So that's four of the SI units that we're going to really be talking about in this class. The last one is not technically an SI unit, but we will be talking about it, so I briefly want to mention it, and that is volume. And it's not technically a SI unit because it's actually just more of a measurement of length. It's a combination of length. All right. Volume is the 3D space taken. So it's how much space does a 3D object take up, whether it's literally you. How much space are you taking up? Not how much stuff is in you. The amount of stuff in you is mass. Volume is how much space do you take up. And it's a three-dimensional. Area is a two-dimensional. Volume is a three-dimensional space. All right. And so typically we measure that in units, since it's, the easiest way to think about this is like a cardboard box, right? How much space does it take out? Not how much stuff is in it, right? So you can have an empty box or a full box. There's different amounts of stuff in it, but how much space does that box take up? And that is the volume. So we typically measure that in meters cubed if it's a solid. By meters cubed, literally meters cubed. All right. If it's a box, it'd be length times width times height. Meters times meters times meters, meters to the third, or meters cubed. All right. And if you're doing, but that only works for solids. If you're doing a liquid or gas, because I can't take a ruler up to like my glass or up to the air in here, I could measure the size of the room, and that could give me the volume of the air in there. But sometimes what we'll do for that case is we will use liters cubed, or milliliters cubed is actually more often than liters cubed. But we could use either one of those ones. And depending on what we're using, we're either using a ruler to measure meters, or in this case here, we would be using a tool called a graduated cylinder. All right, so, so these are the 5 that we're really going to be talking about. Again, we have our SI units here. We got 4 of the 7 here. The ones that we didn't talk about, the amount of a substance, which we use moles to measure that, luminosity, which we use lumens, and electrical current, which we use amps. These 4 of them are the SI units, and I included volume just because it's used so often in these things. Major relevance, like density, is really a measurement of how much stuff is in how much space. So those are the introduction to the few SI units that we'll be using. Just a real basic about what they are, what units they use, and the tool that is most commonly used for it. So, all right. Go back if you need to watch it in case you missed anything. Otherwise, it's all you can pause and kind of take a look at it. And I'll see you. Good luck. May the science be with you.